Hello, my name is Zaria Coprich, and today I'll be presenting client-server and peer-to-peer architectures and multiplayer games. What are multiplayer games? Let's begin with that. Multiplayer games are any game that allows two or more people to play together. And multiplayer games, when they're created for online use, they tend to include netcode. Netcode is an umbrella term that covers several networking aspects used in multiplayer games. So netcode acts as the basis for the network architectures. The first architecture is the client-server architecture. In the client-server architecture, there is two roles. There is the clients, which are normal people, the users. They're the ones who will send their requests out to the server. The server typically contains most of the data. And from the request, the server will process it and then send back a response to the clients. It tends to be, it can minimize application development, increase system procedure, and is a more direct and relatively simple approach for developers. There are two forms for a client-server approach. There is the server-centric, also known as thin client, where majority of the game resides on the server. This is what we're most used to. Client systems are mostly tasked with displaying the game and allowing the users to interact and send responses through. However, there is the client-centric or thick clients. This is where majority of the game logic is residing on the client systems. So the server's main goal is to act as an administrative front. So it's tasked with providing maintenance and providing the administrative tasks. Now, in most network architecture setups, there are two-tiered and three-tiered approaches. However, in massively multiplayer online games, also known as MMOs, they tend to take a four-tiered approach. So the first tier would include the client layer. The client layer is basically where the client accesses the MMO through some application. Then there is the proxy layer. The proxy layer acts as the bridge between the client layer and the game layer. It also acts as the firewall. So depending on the availability or accessibility the client has, determines how much of the game layer the client is able to receive. The game layer contains all the game logic, all the information related to the virtual world of the MMO. And finally, the database contains all the data related to the game, from the user information to what time an event should be occurring. It includes all that. There are multiple techniques used for distributing the game layer. There is sharding, which creates or runs various versions of the game on different servers. There is cloning, where all servers attempt to run the exact same game, it just distributed across multiple servers. There is zoning, where the game world is separated into multiple zones, so it will decrease the amount of load on the server. And then there is instancing, which combines sharding and zoning. There are multiple benefits to the client-server architecture. It is easier to update. They tend to have a single game state. It has more of a governing authority, so it prevents cheating, or attempts to. And it is more commercially exploitable. However, there are multiple flaws. Building a client-server architecture tends to be expensive. It can have a single point of failure. And because it's expensive, it tends to have a lack of scalability and flexibility to its build. Next, we'll be talking about peer-to-peer architecture. This is where instead of separating into a client role and a server role, all computers on the network perform basically the same thing. Both of them, or all of them, are their own clients and their own servers. So they act as peers to one another. So the users on peer-to-peer architecture contribute their computing resources to the network. And it attempts to reduce the need for a centralized node. Though there are some peer-to-peer architectures that include a partly centralized node, so it can contain the very important information needed for the network to run. There are multiple multiplayer games that use peer-to-peer architectures, but it doesn't tend to be used in MMOs. Instead, they tend to be used more in fighting games. Though there are some multiplayer games, or MMOs, that use the peer-to-peer architecture as their basis, such as Age of Empires. Though I believe now Age of Empires has taken more of a client-server approach. There are two main common types of netcode used in peer-to-peer. There is the delay-based netcode, where the delays the local players' input to match with the netcode of the remote players. And then there is the rollback netcode, where it will attempt to predict the user's input if there happens to be a delay. And then when the user's proper input goes through, it will roll back to that section of the game, or that frame, and input or place that user's input there. So, for example, for a rollback netcode, let's say we're playing rock, paper, scissors. You choose rock, and I have a delay on my end. Well, the server will attempt to predict which of the three options I will choose, and it predicts I choose scissors. Well, rock beats scissors, so it's going to act as if you have won. However, instead, my original input was rock. Well, the server will then roll back to the point where the inputs were processed, replace scissors with rock, and now it's a tie. There are multiple benefits to a peer-to-peer architecture. They tend to be more robust, they are more scalable, and they have a low financial cost. However, there are multiple flaws as well. There is a lack of a central authority, so it is easier to cheat in a peer-to-peer architecture. There is no single global game state, or it's not easy to recognize as. It is not as financially exploitable compared to a client-server architecture. And in regards to MMOs, they are complicated to build and include. So in conclusion, client-server architectures tend to be used for a large number of players, especially if these players need to be interacting with one another simultaneously. The MMOs tend to have a 4-tiered architecture structure, and they tend to be expensive. Peer-to-peer architectures tend to be used for a small number of players, from 2 to maybe 8. They have either delay-based or rollback netcode implemented into their structure, but they're underutilized, so there isn't as much research included for them. And I would like to thank Dr. Ghosh for sponsoring me and helping me out with this presentation. I would like to thank the Department of MCIS I'd like to thank the College of Science and Mathematics. And overall, I'd like to thank you all for being here. And these are my sources. Are there any questions? Yes,
I have one on that rollback netcode. I think, obviously, this has to happen really fast, or your game would just screech to a halt. So when it anticipates what your answer might be, is there some kind of machine learning that looks at your responses, or is there an optimal, does it assume you'll make the optimal choice, or does it just randomly pick something and then correct it when it has to? How does that work?
First, it will attempt to be more of a machine learning. Well, first it will predict based on what's most optimized. But as the game continues, it will learn like, okay, this player tends to use this input, so this will be the input we'll use the most.
So even if it's a bad play, it will mimic your bad play?
Yeah. So if you were trying to switch up your bad play, it will attempt to fix itself.
Okay, cool.
And in regards to like how quickly it does occur, it goes by there's a section called frames per second, and most games attempt to implement a 60 frames per second. So most of the time a delay will occur during the first half of a second. So it will be a bit difficult if you're not used to seeing it to notice the rollback or to notice the delays occurring. But because fighting games, which is where it's mostly implemented, are so reactionary and muscle memory, that delay or so can cause an issue.
Thank you.
I think sort of I kind of want to bounce off that. Like a controversy that I remember from like a few years back was a game called For Honor. When it first launched, it used peer-to-peer servers instead of dedicated. I think it fixed the problem after some time, but it was a game that required like a lot of like instant reaction time, and like because it was like a third-person kind of fighting pseudo like combat game. But like because it was peer-to-peer, and if the host wasn't like in I guess like the same server region, it would just ruin it for everyone else because it would make the game almost unplayable at times. So I think it's kind of important to understand the distinction between those different types of games.
Yeah.
I really like it.
The delay-based netcode is the most commonly used because it's the simplest one, but just as you said, if there's like a distance between the remote user and the home user, there will be a lot more delays than if we were sitting in the same room.
Was the MMO designed more for security or performance?
A mixture of both, because especially for the proxy layer specifically, because it acts as a firewall, it can help determine whether or not, like, how much the client is able to access that MMO. If they have, say, World of Warcraft, one of the most popular MMOs, you can have the base game, and the proxy layer will recognize you have the base game, but it will not give you access to the expansions because you haven't purchased the rest of the expansions. So it helps to prevent, like, or help organize clients based on what they are provided. Any more questions?
All right, let's thank our speaker again.